Hello everyone, welcome to Lucky Learning. Here in this video, we are going to discuss the important topic for your examination, that is addition and subtraction with signed two's complement data. In most of the times, this question was asked in your semester exams. So listen to me carefully. I'm going to explain you in very detailed. Here, for reference, I'm showing you when here look at perform -25 plus -10 in binary with negative numbers in two's complement, and also given explain flow chart for addition operation with signed magnitude data. Right here you can see it is in March 2022 paper. It is given explain the subtraction operation with signed two's complement data. You can see in the next paper. Here, it is a 15-mark question in 2021 paper. Perform arithmetic operation plus 41 plus minus 13 and minus 41 minus minus 13 in binary using signed two's complement representation for negative numbers. And in the same year, derive an algorithm in flowchart form for adding and subtracting two fixed point binary numbers when negative numbers are in signed two's complement representation. See, in the same 2021 year, this topic, from this topic, there are two questions given, and both are for 15 plus 15, 30 marks from that topic. So you can understand what is the importance of the topic. And here look at in 2020 paper, again you can see here is a question, perform arithmetic operations plus 42 minus plus minus 13 minus 42 minus minus 13 in binary using signed two's complement representation for negative numbers. See, these many number of times question is asking, it means you can understand the importance of it. So listen to me carefully. Addition and subtraction with signed two's complement data. Here we should know that the numbers, both positive and negative numbers, are to be represented in two's complement form. Actually, if it is a plus 6 is there, if I have to represent a 4-bit number, plus 6 is to be represented with 0110. If it is to be minus 6, we have to take the two's complement of plus 6. It is going to represent a minus 6. Means, how do you get a two's complement of plus 6? That is 0 unchanged. First one also be unchanged, and the remaining bits are to be changed. It means 1 changes to 0, 0 changes to 1. Now we can call it as a minus 6. Now here it is 2's complement plus 6. It is 2's complement minus 6. Means it is a 2's complement representation. In 2's complement representation, positive numbers are, it is represented as normal binary numbers. But 2's complement of positive numbers will give you. And when it, what is to be done? We have to add the two numbers, including their sign bit. Here, what is that sign bit? The most significant bit will be used as a sign bit. Here, most significant bit is 0. We can call positive number. Here, most significant bit is 1. We can call negative number. And when you add these two numbers in signed two's complement form, if you get any carry, that carry is to be discarded. Simply to remember, discard any carry when you perform addition of two numbers using signed two's complement. If the sum obtained after the addition is negative, how do you know that sum obtained after the addition is negative? It means when you see in the result the sign bit equal to 1, we can call it as a negative number. It is a negative number means the number is in two's complement form. Simple. Add two numbers including their sign bit. If any end carry resulted, discard it. If the sign is negative, if the sign is 1, it means the result is negative. We can call the result is in the two's. Now, look at algorithm for subtraction. So in subtraction, how do you do this? Suppose a minus b we have to perform. We have to perform a plus of minus b. It means, how do you get this minus b? A plus minus b you can get by using the two's complement of b. The two's complement of b is called minus b. It means even subtraction also we have to perform using the addition. So means a minus b means a plus of minus b means we are performing addition, but minus b we are going to represent in the form of 2's complement of b. Here you look at, take the 2's complement of subtrahend. Here you should understand, here a is called minuend and b is called subtrahend. A is called minuend, b is called subtrahend. Okay. Now take the 2's complement of subtrahend, that is including the sign bit, and add it to the minuend. Add it to the minuend including the sign bit. Suppose any carry out of the sign bit position, and that is going to be discarded. We know that carry is going to be discarded in the addition operation. Look at here, plus or minus a minus plus b. It means, how do you do this plus or minus a minus of plus b? Plus or minus a plus of minus b. How do you take the minus b? 2's complement of plus b will give you minus b. Same logic. Here you look, plus or minus a minus of minus b. It means that minus of minus we can call plus. So we have to perform the addition only, right? Now look at some examples. Here the numbers are represented with 8-bit number, 8-bit numbers. Plus 6. Plus 6 is in 8-bit numbers we have to represent in this way. Plus 13 using 8-bit number. And their addition will give you plus 19. Simple. How do you perform addition? 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 0, carry 1, 1 plus 1, 0, carry 1. Because carry 1, this is a number. And what is the sign? 0. 0 means positive, and the result of this magnitude is 19. And when you look for minus 6 plus 30, how do you get minus 6? So minus 6 is the 2's complement of plus 6. So least significant 0 unchanged. First non-zero is also unchanged. And remaining bits are going to be flipped. Means these remaining bits. 1 changes to 0, 0 changes to 1, and so on. So that it is going to represent a minus 6. Now minus 6 plus 30. What is going to happen? Now the result is plus 7. 0 plus 1, 1, 1 plus 0, 1, 0 plus 1, 1, 1 plus 1, 0, carry 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 1, 1 plus 1, 0, you are going to get end carry. What we have to do this end carry? This end carry is going to be discarded and the result is plus 7. Now look at plus 6 and minus 13. How do you get minus 13? 2's complement of plus 13 will give you minus 13. Here least significant 1 bit is unchanged. Remaining bits are, so that it is negative. What is the result? Look at 0 plus 1, 1, 1 plus 1, 0, carry 1, 1 plus 1, 0, carry 1. So you are going to get 1 and remaining are 1. Now here the result is minus 7. How do you know that? Because the sign bit you look at. The sign bit is 1. It is meaning that. And what is the value of this number? If you want to see it, just take 2's complement so that you can understand. 2's complement, how do you take? First least significant non-zero 1 as it is. And remaining bits are going to be flipped. Means zeros changes to ones and ones changes to zeros. Right? Ones changes to zeros. Means what is this number? This number is plus 7. Means 2's complement of plus 7 you can call minus 7. Means result is in the negative. Look at in the same way minus 6 and minus 13. Addition. You are going to get minus 19. Same way. Look at for the subtraction of 2's complement subtraction. Now look at minus 6 minus of minus 13. It means that minus 6 minus of minus 6 plus 13 will give you minus 6 in 2's complement form, minus 13 in 2's complement form. Between them we have, but look at and take the 2's complement of minus 13. Here, how do you represent this minus 13? That we have to represent in the 2's complement form. And because minus of minus, it is a plus. Now 2's complement of, now perform addition between these 1, 0 plus 1, 1 and carry 0, 1 plus 0, 1 means carry 0, 0, 0, 1, 1, carry 0, 1 plus 1, you are going to get 0 and carry 1, 1 plus 1, 0, carry 1, 1 plus 1, 0, carry 1, 1 plus 1, 0, carry 1, and 1 plus 1 0, you are going to get end carry. What we have to do with this end carry? End carry is going to be discarded and the result is called plus 7, right? What is this called? End carry. That end carry is removed and we are going to get the number that is plus 7. As we know that minus 6 minus of minus 13 will give you plus 7. That is the result in the 2's complement. Now, when it comes to the hardware implementation, how do you do this 2's complement addition and subtraction? So to perform addition and subtraction, like whenever you perform a plus b or a minus b, it requires to have two numbers. Even in the case of addition, we can call addend and argent, and when it is called subtraction, we can call minuend and subtrahend, right? So assuming the a value in the AC register and b value in the BR register, because whenever you have to perform addition or subtraction, finally we have to perform addition. Why? Because a plus b we requires adder circuit. A minus b also requires adder circuit. How? Because a minus b we have to perform it as a plus of minus b. How do you represent minus b? Using the complementation. What it will do? It will take the a value from AC register, b value from BR register. These two are added and the final result will be stored into the accumulator register, means AC register. This addition may causes any overflow. That overflow bit will be stored into the V flip-flop. V is called overflow flip-flop. When it comes to the flowcharts, look at it is a simple flowcharts. Addition requires to perform addition of two numbers A plus B. A value in the AC register accumulator, B value in the BR register. So A value in the AC register is called argent, B value in the BR register is called addend. Argent, addend. And between them we have to perform addition and the result is stored back to the accumulator. If any overflow occurs, that will be stored into the V flip-flop and end the process. When it comes to the subtraction, simple flowchart. Subtraction means A minus B, means AC minus BR. AC is called minuend, BR is called subtrahend. How do you perform subtraction? AC plus of minus BR. How do you get minus BR? 2's complement. 2's complement means 1's complement of BR plus 1. We call 2's complement. 2's complement of BR is called minus BR. AC plus 2's complement of BR, we can call AC minus BR. Result is stored into AC. If any overflow occurs, that is stored in the V flip. End the process. Now look at what is overflow. Here for the short answer questions. Like what is a overflow? When overflow occurs, and how overflow can be resolved. These kind of questions are possible. Look, when overflow occurs, when you add two n-bit numbers, means when you add two numbers of n bits each and the sum occupies n plus 1 bits, then we can say overflow occurred. Why? Because if two registers having n-bit numbers and addition causes n plus 1, because the register capacity itself is n bits, how it can store n plus 1 bits? No. Then we can call it as an overflow. An overflow is a problem in digital computers because width of the register is always finite because fixed. And if the result contains n plus 1 bits and that cannot be accommodated in the register, so that we can call it is a overflow. And how we have to detect an overflow? So the detection of an overflow after the addition of two binary numbers depends on whether the numbers are considered to be signed or unsigned. So here, if two n-bit numbers are added and you'll get n plus 1 bits, we can call it as an overflow in the case of unsigned numbers, where we are going to assume all the numbers are in a positive form, right? Here, look at when two unsigned numbers are added, an overflow is detected from the end carry out of the most significant positions. If carry occurs, then it is called overflow. For signed numbers, you look at. For signed numbers, the detection of overflow requires. An overflow condition can be detected by observing the carry into the sign bit position and carry out of the sign bit position. If these two carries are not equal an overflow condition is produced. It is a meaning that if the two carries means the carry input to the sign bit and carry out of the signed number. Now look at a simple example here. Plus 70 plus 80. Plus 70 we have represented. Now what is the sign bit? Sign bit and plus 80 is two positive numbers. The result should be positive. Means what is expecting result should be 150. But what is happening here? Look at 0 plus 0, 0, 1 plus 0, 0, 1 plus 0, 0. This is 0, this is 1, this is 0, 1 plus 1, 0, and you are getting carry 1. So means it is a carry input to the sign bit called 1, and it is going to give the carry output 0. Here, what is a sign bit? 1. It means when you add two positive numbers, you are getting the result is a negative number, then I can call it as an overflow. How you are going to detect? You are going to detect it is overflow or not by checking the carry input to the sign bit and carry out of this bit. So if carry input to the sign bit and carry out of the sign bits are different, then we can call overflow for you. Hope you have understood this topic very well. Hope you are enjoying. Thanks for watching. Please do like, share, and subscribe. If you like the video, please share with your friends. Thank you.